Following his conversation with Thomas Alexander Mies, an engineer and an entrepreneur, he is the CEO and co-founder of Radium Energy, a company that's developing small nuclear batteries. And in this conversation, we talk about nuclear energy, nuclear batteries, low-frequency antennas, electrical engineering, aerospace engineering, and an array of technical content that you guys are going to absolutely love. He's one of the most brilliant people I've ever gotten the chance to speak to, so let's go ahead and check it out. All right, well, Tomas, welcome. It's great to have you. I guess I'm gonna get started right into it. And when I looked at your background, it says that you have background in mechanics, aerospace, and telecom. So can you just give us a little bit of your engineering background, your interest in engineering, and how you came to be in the position that you are in today as an engineer?
Mm-hmm. Yeah, absolutely. So I started my studies straight after my Matura exam. It was in 2011, and practically since always, my primary interests laid in mechanical engineering, in railway engineering. Railway vehicles were my best interest. So I started studying at the Faculty of Automotive and Construction Machinery Engineering in 2011. But my first year of study was quite easy. There were no very big issues, no severe exams. I practically had no exams at all. And yes.
Oh, hi there. Okay, so we have a guest on the interview. Okay.
Yeah, so I had no exams at all during my first year, so I decided that maybe I could use a little bit more from my university. I started studying at Warsaw University of Technology, which is the best engineering university in Poland. Mm-hmm. So I peeked a little bit into the Faculty of Power and Aerospace Engineering, as I also gradually became interested in airships, in Zeppelins. Lighter than air aircraft, also including balloons. So as my first year at those vehicles and mechanical engineering started to be quite light, it was quite light, I decided to begin my second studies, which were practically simultaneous with the first.
So was that kind of like a double major, like you were kind of studying two areas simultaneously?
Yes, it was simultaneous. So I started my second year of studying simultaneously on two faculties. Sure. It was a challenge. Hopefully those faculties were not far away from each other, like 6 minutes by tram, so not very big deal. And not so many conflicts within the schedule of courses. But yeah, it drained a lot of energy. Many times I had to start my courses at 8 a.m. and finish everything, including my other activities, at 8 p.m.
Oh, wow.
So it was quite exhausting, but I felt that I was alive. And I had so many wonderful courses in mechanical engineering, also in mathematics, in physics, different areas of physics. Later on, what appeared were courses and subjects devoted strictly to railways, to railway technology, and to aircraft, flight mechanics, aerodynamics, and so on. So the studies became more and more interesting. And ultimately, in 2015, almost simultaneously, I have completed these studies, and I have two bachelor titles.
Oh, very cool.
First one is in mechanical engineering, and the second one is in aerospace engineering. But later on, I decided to start my master's, but I didn't do two faculties at the same time. I was like too tired with all this.
And I'm gonna pause you. Why did you decide to do your master's? Like many engineers will just finish their bachelor's degree and just go get a job. What was it that made you decide to do a master's degree?
Shortly before I started my studies, my engineering studies, I figured out that I would aim for a PhD.
Oh, title. Cool. So you decided early on that you would probably continue in graduate school.
Yes. I wanted to continue that. Also, at least it's a Polish or at least European perspective that the PhDs or at least masters are able to get better positions within larger companies, and especially those positions which require some duties regarding company management, things like this, generally speaking. But of course, higher degrees, higher titles also require more experimental activities, more research, and that is something that I love. So for me, it wasn't a difficult decision to make that I want to pursue with my master's and later on with my PhD. This is something that was very, very natural. I do not really like, or I wouldn't like to have a repetitive job that wouldn't allow me to discover new things. This is not something I would like to do. So something more scientific with more experiments, this is something I love. And I thought that master's and PhD would lead me to this. So yeah, immediately after I have finished my two of my bachelors, I enrolled onto master's that lasted for 4 years, master's in astronautics. Just one faculty, no more two faculties.
Specializing, because in a graduate level program, you kind of need to specialize in one area. You can still maintain broad interests, but you have to get good at one thing, right?
Yeah, exactly. Formally, my master's was in aerospace engineering as well, but it was specialized strictly in astronautics, and I had many specialized courses and laboratories regarding astronautics in Space Research Center of Polish Academy of Science and other space companies in Poland, and so on. And shortly before I have finished my engineering studies, it was in 2014 in February, I started developing a project, an experimental project, which would ultimately become my PhD project, with which I applied for my PhD in 2017. And when I finished my master's in 2017, I immediately started my PhD, and I'm finishing my PhD right now. So yeah, I've been constantly at the university as a student since 2011. That's more than a decade now.
Right. And for me, it's very similar. I'm also nearing the end of my PhD. So I've been in school for, I think, 9 years. So I know the feeling mutual. But one thing that you mentioned is something I also have in common is doing a master's and a PhD was almost like a permission to keep exploring your curiosity and keep exploring your interests, because I also, similar to you, when I was an undergrad, had an experience where I had an internship that was very repetitive and I just hated it. I need to be stimulated and I need to learn and capture complex things. So it seems like that's your path. But I mean, it clearly sounds like you have many interests. So again, in light of needing to specialize and getting good at one thing, how do you balance so many interests, and how do you kind of stop yourself sometimes from going in some rabbit holes too deep, or do you kind of let yourself explore and roam freely? Like, can you talk a bit about balancing those interests?
Yeah, well, obviously I have to prioritize. And currently my interests that are directly related to my PhD have the ultimate priority. I'm still active in, let's say, railway industry. It's non-governmental, but yeah, thanks to my experience as an engineer and as a scientist, I am still useful there and I'm still active there. But it's more like a part-time activity now. Well, sadly, still railways are deep in my heart, but I am quite more busy with something else right now. I did my master's in nuclear engineering. It was like a composition of nuclear engineering and astronautics, something in between. So this aspect evolved into my startup, into my company that I'm developing right now. So what I am doing nowadays is more like balancing these two factors, the PhD factor and the company factor. Stratospheric radio VLF engineering and nuclear engineering, and balancing that and also adjusting myself and my work to this different type of activity. I mean, PhD is very different from those earlier degrees of studies, because you are doing mainly, of course, your own project in your prime time. In the past years, during my previous studies, I also did similar projects,
Sure.
but they were all part-time projects in the evenings, on the weekends. And now the same topic became my primary activity.
Sure.
So I had to maybe not physically reschedule everything, but reschedule it in my mind, that this is something that I now do during the day. And in the evening or the weekends, I do have to relax. I have to reduce the stress that I am subjected to constantly. Because, well, these things do excite me, but they are also stressful.
Yeah, they're very mentally they involve a lot of mental computation on a constant basis. So you are constantly drained, even if you like it.
Yeah.
You're exerting a lot of
That's
energy.
true. So I had to adjust to that, and actually the balance between those two main factors, so my PhD activities and my company activities, depends on many things. Also, it depends on the time of the year, because, for example, during the holidays, I'm more active in my company than in my university.
Sure.
Well, I try to for example, during a working week, I try to separate activities from, regarding the know-how in my company with my PhD activities. For example, this day and this day, I'm working with some aspects for my company, some experiments, some computations, some analyses for my company. And the next days, I'm just focusing strictly on my PhD. I'm sitting at my computer in my laboratory. I'm working, I'm analyzing the data. Okay, that's what I am doing. I try to separate it like this, and it seems to work quite efficiently.
So it works when you separate them in terms of days. So you allocate like a day or two, because some people may allocate, let's say, within the same day, 4 hours towards project one, and then like 4 hours towards project two within. But like, do you think, from experience, have you tried that? Do you think it's better to just allocate the whole day to one project?
Well, for me, my activities are very immersive. So I try to allocate it in the scale of an entire day. It allows me to finish the activities that I am currently doing, with me being satisfied by the results, satisfied by what I have done, how it looks like, that there are no more questions, no loose ends, and to actually be satisfied of what I have achieved during these activities, I must have a full, calm day to have it completed.
Sure.
Of course, it does not apply to activities like sending emails, like controlling invoices, or controlling the taxes documents and so on for my company. This is something I have to do on a constant basis, being in constant contact with the rest of my shareholders. The activities that are related directly to the know-how and experiments for the company, this must be separated on a daily basis. This allows me to complete it in a way which satisfies me as an engineer and a scientist. Of course, if more questions arise or I am quite unsatisfied with the result, I may allocate more days for it to have this problem solved. But it rarely happens. A full day is sufficient to complete a task that I have created for me. Right now, I am finishing my PhD, so this type of work is even more important for me, and it seems to give very good results, actually. Day by day, task by task, and full day, a single just one type of activity, no sharing between hours.
And that makes sense, because I've read that like task switching is really bad, because kind of you mentioned that you like to make sure that you finish the task and everything is resolved, because if it's not fully resolved and you move on to the next thing, a portion of your brain will still be concerned with the previous task, and you won't be able to be fully computationally efficient, right?
Yeah, absolutely, absolutely. And my attention is like being diluted, being lost.
Sure. Yeah. And can you can you walk me through like what a typical day looks like? Let's say one day for your company, you have to tackle a big technical problem and you're going to immerse yourself in it the whole day. For the people watching, the students who are curious, what would that look like from the time you wake up till the time you go to sleep?
Well, usually it looks like that's the beginning, in the beginning of the day when I wake up, drink my tea and so on. I check all the emails, I check all the invoices and any kind of this type of work. So answering questions, filling documents, checking the invoices, and so on. And then I try to gather my resources to start solving the problem. I can make contact with other shareholders of my company, among which I do have a space qualified electronic engineer, which is a great help of mine, and
Sure.
he verifies my ideas and my experiment. He's very useful. So I may talk to him. I may go and do the shopping, really. I mean, shopping for the experiments if I have to carry out something and or build something special. Then I also do it in the middle of the day. I have to remember to eat. This is sometimes difficult, but I
Sure.
have to. And usually after that, it's been already 4 hours, for example. After that, I sit and I work for about 5 hours with only just short breaks to finish the problem, do the
Sure.
experiment, deliver the data, analyze the data, come up with the results, and well, afterwards, usually I also check how does the
So
the company
in
function.
those 5 hours, I'm guessing you make sure that you're not interrupted, right? So it sounds like in the beginning of your day, you go through emails, you talk to
Yeah.
everyone, you make sure the world is not falling apart. And then once you have checked all these boxes, then you kind of almost isolate yourself. And for those 5 hours or so, you're solely focused on that one task with minimal distractions, right?
Yes, I try not to be bothered with any other tasks, but this does not mean that I am isolated from people.
Sure.
I like to work in the environment that I've been working for the past 10 years now. So in my students association, to which I still belong, it's the largest association one of the largest in Poland, and in our university, it is the largest. We have 200 members,
Sure.
and I'm one of the senior ones right now. But
Yeah, you've been there
nevertheless,
for like 10 years.
yeah, but well, nevertheless, I like to work within this environment. When I see people somewhere around me, they do not bother me really. They
Sure.
do not dilute my attention. But yeah, I may speak to them. I may answer some questions if they do. Usually, they do have some questions for an older student, but
Sure.
I
So,
do
so,
not
so
like.
that energizes you. It doesn't take away from you. It sounds like being around those
Yes.
other motivated students puts you kind of in the groove to be more productive.
Yes, and the fact that there is something also happening in the background actually makes me a little bit more relaxed
Yeah,
in a quite strange way. And actually, I found that this is the way I work much more efficiently and much faster regarding all my analyses. Also, if there is somebody around, I can simply share with when something that
sure.
satisfies me, or something when something simply makes me happy because I see that my analysis, for example, makes sense, then this is also quite rewarding to have somebody nearby to share this
Yeah,
joy. I expect that in a few years a similar environment would arise in my company, but right now we're a very, very small company, so there is no such environment in
sure.
there. But I hope it's just a question of time.
Yeah, so do you currently use that environment, the student association, student space for both your PhD work and your company work?
Mainly for my PhD work.
Sure.
For my company, not really. I have developed most of my company's work somewhere else. yeah, it was dependent on many factors.
Sure.
So yeah, I couldn't do that
So does your
within this
company have
environment.
its own like office space where you go and do work, kind of?
Not really. I do it at home.
Okay.
I do my works for my company at home. I have some equipment that I cannot really bring to
Sure.
my university because it would cause problems, because it's not the equipment that belongs to the university, and so on. Yeah, the
Yeah.
majority of the new know-how for my company was not done in that place, with an exception of the very first elements that became a foundation for my company. They were done in that location, in that environment, with
Sure.
lots of people around. But it was in 2017 I did my master's in this, so this is slightly different from what we are doing in my company now. It evolved,
Yeah.
and it's quite, from practical point of view and organizational as well, it became more separated from the university activities, from that environment. But I found for my PhD, finishing my PhD, that working within this student environment, this is something that really helps me to keep up with what I have to do.
Sure.
And I work much more efficiently and much faster. I didn't expect it to look like this, but it did. It did, and I have managed to master this method during last year,
Uh-huh.
and it really brings very good results. Not only just simple progress, but also more
Yeah.
articles and so on. So yeah, I'm quite happy that it works.
Yeah, that's amazing. And actually, I'm glad that you were bringing up this contrast between PhD and your company, Radium Energy. Can you tell me a bit more about Radium Energy? I mean, you guys make alpha voltaic cells for Internet of Things applications. For someone who has no idea what any of these things mean, what do you guys do, and who are you targeting? Who are you trying to sell to? Tell me a bit about Radium Energy, your company.
Yeah. So Radium Energy was founded in 2020, 3 years after I finished my master's. And it's a direct result of what I did during my master's. In my master's, I have imagined that nuclear radiation coming from ordinary radioactive materials that can be encountered even in a natural environment, that this radiation actually transfers electric charge, or is able to induce electric charge when being absorbed in certain materials. So I started to analyze this, I started to read about it, and I started to make experiments with it at the university. And this was my master's, this proof of concept nuclear batteries. I decided then, as these projects were not that severely bound with the university,
Of course.
I have decided to I thought that maybe it would be possible to make a company out of it, because there's something really, really new. Only a few more other companies, mainly from the US, do it. There are many different designs, many different versions of this technology. So we are able to bring something new and something that is not a copy of anything. And as these sources are usually not very powerful, we can make our target group the Internet of Things, which is developing exponentially. There are many different types of designs, types of circuits used within the Internet of Things that with our batteries would be able to expand the entire Internet of Things network towards the environments that were previously unreachable. For example, the internal spaces of some buildings or constructions or walls, or, for example, sensors placed over very large or long networks like pipings or tunnels. We have already been approached by 2 companies that manage water pipings in Warsaw and near Warsaw, and they want to reduce the cost of maintenance of the sensors that monitor it. And this reduction can be done using nuclear batteries as well. The nuclear battery itself, I haven't explained that yet.
Yeah. But
Is
I was
something.
just going to say, like, how does a nuclear battery compare to like a solid state or lithium ion battery? Now is probably the perfect time to answer that, right?
Mhm. Yeah, well, nuclear batteries have much greater power density if we compare it without analyzing the dimensions and so on. But usually nuclear batteries have much lower powers in comparison to the batteries that we can buy in any kind of electronics or shop or newsagents or whatever. Of course, the fact that these batteries are nuclear and they rely on the nuclear decay of a certain isotope, it means that their operating time is proportional to the time of decay of this isotope. It means that such a battery could be active for 100 years for nickel 63, more than 600 years for americium 241, and more than 1,600 years for radium. And this is
Wow.
actually amazing because even if this battery lives longer than the circuit that it powers, a very small circuit, of course, then it means that there is practically no need for any kind of service for these
Sure.
circuits, unless the circuit itself breaks. But this is not the question of the battery. It is a question of the circuit, of the transistors, of the capacitors, which are very susceptible for leakage and drying. So the reduction of costs and employment of electronic sensors in previously unreachable environments is something extremely tempting, not only for the IoTs, but also for any kind of special electronics. And by
Sure.
special, I mean, for example, sensors that are put deeply underground and they sense vibrations. That's, for example, an idea given to us by Estonia, a country that, of course, has a very long border with the country which name begins with the letter R.
Sure.
So they're interested in monitoring the border and without the need of
Like constant
putting,
maintenance and servicing.
yes, and power supply cables or recharging it. Well, how if it's deeply underground? It's difficult. So yes, so this is one of those special applications that we were approached with, and there are more. We are discussing them right now in this weekend and next week. However, we are bound with certain NDAs and so on, so we can't
Of
really talk
course.
about it. Yeah, these applications are related to security, to very high levels of
Yeah.
security, which means that the electronic circuit supplied with power from these small natural nuclear sources wouldn't be susceptible to any power losses. It would operate in any conditions, and the cutting cutting off their power would be practically impossible, which of course it's a great asset.
Yeah. So in the case of like electronic or electromagnetic warfare, like which is something that's very rising, you'd say nuclear batteries are a bit more robust against these type of techniques or like jamming or things of that nature.
Yes, well, absolutely. Jamming, I'm not sure about jamming, but they are definitely very robust and resistant towards any kind of manipulation with the power sources. From maybe less dangerous point of view, a very good example is a very wide network of alarm sensors installed in a
Sure.
building. Usually, these alarm sensors are powered with very small batteries that are depleted in a very irregular basis.
Hmm.
So it's quite not only annoying for a person which has to maintain this network, but it is also very well. It makes this entire system well susceptible to weak points because the protection given by the sensors, provided by the sensors, isn't the tide. So giving these sensors a power source that can last, well, maybe for not 600 years, but even like 20 years or 30 years, it would mean already a lot. You can't cut off the power to these sensors because they have their own power. They will work, they will be powered, they would work regardless of their age. So they are able to provide the protection, well, almost all the time. And there's, of course, no need of purchasing next batteries and physically changing them. So this is another cost reduction for whichever entity owns this network. So, well, and of course, the entire Internet of Things industry is growing exponentially. It's so large that even if we think about such specific employments, specific applications of this type of power sources, the size of the Internet of Things market means that this niche is actually enormous, and it's still growing. And there are not so many competitors. So it is something that is quite tempting tempting as a critical factor to find whether to found a company or not. So me and my friends decided that, yes, let's do it, let's try it. And we have created Radium Energy in 2020 after a pre-incubation period at my university. My company isn't officially bound within the university. We plan to use the laboratory that is located there, a laboratory in which I have worked previously, done my proof of concept experiments. So they know that we exist, and they are very keen in cooperating with us because this is something new and it has a lot of potential. But we are separate, the company.
Okay, cool. So it sounds like you have full ownership of the company. The university does not have ownership of the company.
Yes, that's true.
Which is actually the best case, since you get to use the facilities and the expertise, but you own the company. So it's
yes, of course, it would mean that we would have to pay for the facilities anyway. But well, yeah, the university does not have practically any rights to what we are doing in our know-how and so on. So that's easier from certain.
But before I ask you some more questions about the company itself, there's a few technical points I want to ask about. One is, if I remember correctly, like NASA Voyager satellites use some type of nuclear battery. Is that correct? And that's why they've been in space for, I think, 40 or 50 years and still operational, still receiving data to this day. However, I believe there are some concerns risen to the safety of nuclear batteries and whether they are like okay to use or not. And I believe that concept was discontinued, at least in space. I think that's probably a very important misconception that the general public has, or people have. Are nuclear batteries safe? If so, can you explain in technical detail why or why not?
Yeah, well, the type of batteries that the Voyagers and the Pioneers and other spacecraft used, these are the RTGs, so the radioisotope thermogenerators. And they're practically converters of heat created by radioactive isotope into electrical energy. There's a thermocouple which converts this object that heats itself up into electrical energy. So it's not a direct conversion of nuclear decay into electricity. There is heat also in there. It means that the RTG is much less efficient than an ordinary nuclear battery, which does this conversion in a straightforward way. So, I mean, directly from the radioactive decay into electricity. And that is what our nuclear batteries are doing. The main concern within the RTGs was that they do not only heat themselves up. So we have an object that constantly emits heat, and some engineers are very reluctant to employ something like this in their designs. I'm not surprised by that.
For good reasons.
Absolutely. And the other important factor was that the RTGs employed critical materials, critical from the point of view of the military. I mean, these isotopes were used for nuclear bombs. So they were not only expensive, they were, well, questionable to be used somewhere outside the military. And that meant that they were not easily obtainable and they were very expensive. Nowadays, there are many attempts to substitute these materials with other isotopes. There have been quite some tests regarding it, but yeah, it's for the future. Mainly, we sadly have to use all those military grade materials, which are, of course, not used in ordinary nuclear batteries, such as the ones that we design at Radium Energy. We use mainly materials which are either natural or that come from the depleted nuclear fuel rods that are being reprocessed. And many isotopes that were created in this used nuclear fuel are extracted and formed into something that can be sold on the market. And this is another important thing for the nuclear batteries. There are many designs of them, and many of them do not employ something that is called an enclosed source. An enclosed source can be compared to a coin inside which is the nuclear material in the form of an oxide, of a metal layer, of whatever. It's covered with an atomic layer of gold or gold and palladium that lets out all the radiation, but the radioactive material is inside and it cannot be extracted using chemical methods and most of the physical methods. These sources are extremely robust. They can be crushed, they can be broken, but the radioactive material is still inside there. It cannot leak out. It cannot react chemically or physically with the environment. So these sources provide the highest obtainable level of protection, and we use these type of sources. So our batteries are market safest, actually. There are other designs of nuclear batteries, for example, from the US companies that have to produce this kind of sources by themselves. But this is much less safe than using an already prepared source in this form of these metallic objects in the way we do. So our batteries are extremely safe regarding all physical conditions and chemical conditions, and they also do not emit heat and do not use any bomb-like materials.
Okay, sure. Wow. So it sounds like the RTGs really are the dangerous or the questionable type of nuclear battery, and the ones you guys are designing, since they bypass this heating intermediate stage, and it's like a fully enclosed source to cell contact, that mitigates the risk quite dramatically. Would you say that?
Yes, I would absolutely agree. Well, of course, those sources that convert the radiation directly into electricity, they're much smaller than the RTGs, because the RTGs are simply creating heat, which is much easier to manage in the energy conversion than the radioactive decays themselves. Well, that's the critical part of the know-how that we are doing. So well, I may say that the first step are these smaller sources, and then with our know-how growing, we would be able to either define a way on how to stack these sources to make the ultimate source more powerful, or we would find out what happens inside such battery if we elevate the activity of the source beyond the activity of, for example, a couple grams of radium. So between a couple of curies, the phenomena inside would be slightly different, but this could actually bring us more closer to the output parameters of higher power batteries, higher power cells. So that's for the future.
And it sounds like the entrepreneur in you saw this disadvantage as an opportunity to target small devices such as IoT devices, right? Since power really is your limitation, that actually becomes your selling point in your company, where you're saying, hey, this works really well for small things, right?
Yes, absolutely. And well, we are of course monitoring also other types of such small batteries of different types of, or simply energy harvesting market. But many of these methods that the so-called energy harvesting for IoT employs, there are always some, let's say, backlashes that come out of these methods. For example, we can harvest our electric energy out of radio waves that are nearby, like for example Wi-Fi or whatever. But the result is we reduce our Wi-Fi coverage because we consume this energy into electricity and not into transmission of information. So yeah, there are many issues with that. There are no easy, straightforward solutions. Yes, there is a very large, let's say, field for new ideas, for new experiments and new products that can help to solve these problems and ultimately to, of course, reduce the costs and expand the possibilities of what the Internet of Things can do.
Yeah, so in terms of timelines, I know usually entrepreneurs hate this question, but when would you expect to have a fully integrated IoT device that is functional, that is solely powered by a small cell nuclear battery?
You mean when? When exactly?
Yeah. Like, what's the timeline looking like of the product development and whatnot?
Yeah. Currently, we expect that this would happen in maximum 2 years, maybe less. Our know-how is quite advanced, and we have already prepared everything for the production of these batteries. So what we need right now is an injection of money and access to the laboratory to simply start working, because this is, well, that's our current stage. We know exactly what we want to do. Everything is prepared for at least prototype production and for testing in a given environment. So I think that in the upcoming months, we have some opportunities for acquiring some funds, and this should allow us to actually begin this work, so that in maximum 2 years we would be able to put the final device and the battery on the table, and not only put it just there, but also present all the data sheets needed and all the test results, so that the final product is already more developed than just something that was assembled out of the parts that arrived. That's our plan, not only have it ready, but also have it tested, so that there would be no issues with implementation, which is of course crucial for the customers.
Absolutely. And do you ever worry about like, have you identified any direct competition? Anybody who might take the idea and try to implement it faster? Anybody who's doing something similar? Like, what are your thoughts on competition in this specific space?
Well, our main competition are, let's say, more classic batteries, so chemical batteries, which are developed by highly specialized companies in this field. For example, SAFT batteries, which also supplies the space industry. So what we are worried about is that ultimately they will come up with batteries that have much prolongated their operating time. Right now it's like, I think 10 years, maybe 15, but they are of course working on making this much longer. So maybe in the upcoming years, it would be announced that their batteries would be able to operate for like 20, 25 years. And they're getting closer to those times that are declared by us. And they have, of course, much more resources than us. So yeah, that's our main competitor. Among other nuclear batteries, well, it's difficult to say because the technologies employed and already found on the market are very different from each other in most cases, of course. So it's not easy to compare directly those, well, apparently similar, but from the point of view of know-how, very different products.
Mm-hmm.
But their current level of, let's say, market penetration is pretty similar between those companies. So we do not really feel endangered by those companies that already exist. We do feel that there may be a customer which would be interested in our products because of the advantages that they give, but they could turn, for example, towards long-lasting chemical batteries because they are not nuclear, well, for example.
Yeah,
So
absolutely.
we would have to, in the upcoming future, expand our team towards a person which would be directly responsible for clients acquisition and any kind of relations with our clients. Because, well, I do not have much experience in talking to clients. I'm an engineer, I'm a scientist,
Sure.
and the rest of my team are also composed of either engineers or people who are fluent with funds and grants, but not necessarily talking to customers. So the translation of all the potential that lies with using our products, the translation of the advantages that our product gives to the clients must or should be done by somebody who is more fluent in this kind of things.
Sure.
That would secure our business for the predictable future. So in the upcoming months, maybe not in 1-2 months, but in like maybe 6, maybe 8 months, we would be looking for a person which would be directly responsible for that, to make sure that the customers will stay there, will buy our products, and will be satisfied with using of what we would provide them.
Sure. So it seems like recruiting is a very important skill that your company needs to make sure that you get the best PR people, the best sales or customer relations people. I can't help but ask, when I read the biographies of some of the greatest entrepreneurs, like let's say Steve Jobs or Elon Musk or Jeff Bezos, they are very skilled at being able to articulate a vision and recruit people to be part of their team and basically build a strong team of people. So my question for you is do you try to study how these entrepreneurs are able to inspire and recruit people to join their teams? What's your strategy for trying to find the best people possible to join your team?
Well, I think that very important factor here is that we have already many connections within either space industry or electronics industry, or even nuclear industry. So if we decide that we need a very specific person, we can target him or her directly because we simply know this person.
Sure.
Or we can ask for such a person to be introduced to us because we're looking for somebody like this. So we would definitely rely, at least in the beginning of our operation as a company, we're still in the beginning practically, we would rely on our own base of knowledge of people that we have met during our previous activities, our previous projects. What is more important, we do not only know these people, but we have previously worked with these people. We know what these people can do. We know what they are not really good in. This also happens. And we know how to talk with them. From some of these people, we have also even now heard that if we had another interesting opportunity or another interesting project, give me a call.
Sure.
That was one of the most wonderful things that I have heard so far as an engineer, that people from my team actually said that if you have another project
Yeah,
that's keeping you
they enjoy the work and they would like to be part of it even more.
yes, yes, this was very heartwarming for me
Yeah,
as
of
the
course.
curator
That's
of
yeah,
projects and experiments.
yeah, that's
So,
as
so
good as
yes,
it gets.
so initially we would definitely rely on our contacts and let's say our own choice of recruitment. We are not the best in public relations. I mean,
Sure.
public relations like in this comparable scale to what, for example, Elon Musk does or Steve Jobs does. But when it comes to talking during some elevator pitch competition like presentation or for example during a conference or even at a gathering of investors of people or people interested from people from the industry, we are able to successfully grab their attention and inspire them. Usually when we describe what our project is about to a person who has never heard anything about it before, it's usually like this person ultimately during our talk starts to develop his or her own ideas of what can be done with our batteries, where it can be put, how could they be used. And it happened very frequently. When this happens, it's like, I remember John Romero. It's like, oh yes, I know they got it.
Absolutely.
So I think that in the future we would have to think about how to expand this kind of explanation of what we do, because this already works in this tiny scale in a personal talk or talking to a rather small group of people, but this must be reformulated into something wider using social media or a website or whatever, so that's it would have a much greater range.
Sure. Absolutely.
And so of course it would affect the potential customers and the potential employees that would see that it is something that is truly inventive, truly new, truly inspiring, and maybe it's a great adventure to start working with Radium. So
Yeah, I think cutting edge technology is always exciting for engineers. I think for an innovative engineer or engineering student, the most terrifying thing you could tell them is, hey, just do this the same way it's always been done, and this is your job. I think many people are probably very inspired by the concept of building something new, especially if it has not been done before. So it seems that you've been able to use that quite well.
Yes, absolutely. However, I must say that there are still on the market, there are still people or engineers that do like this kind of repetitive activity of designing the very same part, but mainly for different applications. But for them, it gives a unique sense of stability, that they know what they are doing, they're perfecting it. Doesn't matter that it's all the same, is the same thing all the time, but they have a stable job and they know that they can perfect it. It's an attitude that I do not share, for example.
Yeah, I don't either.
But I know that it exists, and I have some friends that share this point of view actually. So I think that ultimately in the future it would be also important to recruit this kind of people as well, because not everything in such a even cutting edge technology company relies on making the experiments only. There are also other things that have to be designed, and they are not necessarily so exciting.
Yeah, like manufacturing, for example, you probably need the reliable, stable engineers to manufacture consistently, right?
Yes, absolutely. Yes, absolutely. Or even such soft skills like file management, documentation management, so that there are no issues in versions or in the access to the documentation and so on. This is also very important. So yes, it's the recruitment of people is very, very complex.
Of course, yeah. But that's good. It sounds like you've already gotten an understanding of what type of person does what best, and it seems like you have access to people who are already interested enough in the project. But going off of the concept of innovation, now I want to talk a little bit about the other side of you as an engineer, which is the VLF antennas and the research that you've done for your PhD. And just to give you, by the way, in terms of timeline, I have this call scheduled for 1 hour and 30 minutes. Is that okay with you? We have about 30 minutes
Yeah,
left.
perfectly. Absolutely, yes.
Yeah. So I think we're going to talk about VLF antennas, and then we will close with some advice for engineering students. But let me talk to you about VLF antennas, because I'm very curious about VLF antennas. And can you first tell anybody who's listening what VLF antennas are, how they vary from typical antennas, and what are the challenges? And there's many of them associated with VLF antennas.
Yeah, okay, so the VLF itself means very low frequency. So the radio frequency range between 3 and 30 kilohertz. It means that the wavelengths have more than 10 kilometers, more than 10,000 meters of length. They're very, very long. They're very, very difficult to emit efficiently, but the attenuation of these signals is also very low. It means that they can easily cross the they can easily enter any kind of grounds to a certain depth. They can easily penetrate the border of water. They can enter water also at a certain depth, and they can easily propagate along very long distances in a quite stable way. So they are very, very interesting as a mode for special type of communication. But yeah, the antennas. The antenna is the interface between the transmitting device, the transmitter, the power amplifier, the tubes, the transistors that pump the energy, and the free space. We have to most efficiently emit these very long waves into space. And it is usually said that the antenna itself, in order to radiate the signal efficiently, must have the dimensions comparable to the wavelength. And here we're talking about the wavelengths more than 10 kilometers. 10 kilometers is the size of a small city, for example. So how could we build such a long antenna? We could make it out of a horizontal wire, but it would be very quickly attenuated because of the orientation of the main compound of the electric field that is emitted in there. And the highest mast that has been constructed, so the highest vertical antenna, was actually in Poland. And it existed between 1974 and 1991 when it sadly collapsed due to an error in maintenance. Sure, but it was a little bit less than 650 meters, so it is still not.
Was that a monopole antenna?
Yeah, that was a ground plane monopole that operated on 225 kilohertz. It emitted Polish radio program 1. Now this program is emitted from another site, which has slightly different antenna. There are two smaller masts, but that one was the highest construction until Burj Khalifa was built in 2008.
Sure.
Actually, there is in the series called Abandoned Engineering an episode called the El Dorado Canyon, in which this Warsaw radio mast, this topic is covered, is explained, and I had the pleasure to host that episode.
So very cool.
Please find out Abandoned Engineering, El Dorado Canyon episode. Yeah, but anyway, we need to design a very elaborated antenna on ground if you want to emit very low frequencies efficiently. And of course, it consumes a lot of money, because we have to either build a lot of masts, a lot of towers, a lot of wires. If the antenna is too short, we have to somehow compensate this shortage of antenna with a large inductive coil, which is also quite problematic in installation. I found out, using my experience with balloons, high-flying balloons, that maybe it would be wise to come back to a very old project that dates itself back to 1927, when it was considered that such a very long vertical wire antenna could be lifted up by an aerostat, even up to higher altitudes. So that's there would be no need for designing special towers or masts or whatever as supporting structures, because the antenna simply hangs from the aerostat.
Sure.
It can be very, very long, hundreds of meters, even up to 1 kilometer. The longest one that was anchored on the ground and lifted up by a balloon had more than 4 kilometers of length.
Wow.
And it emitted efficiently, like a quarter wavelength dipole, so a monopole, sorry.
Monopole,
so
sorry.
it worked perfectly. But I thought that maybe it would be wise to unanchor it, to separate the antenna from the ground, let it fly as high as possible and check how is the mission going up there. If we move this kind of emitter closer to the middle plane of the Earth ionosphere waveguide. This is crucial for this type of radio communication.
Would that act as the new ground plane? Because the problem is when you're lifting away from the Earth, you no longer have the ground plane. Is that true?
Yes, we do not have the ground plane anymore. So our antenna needs to have a form similar to a dipole with the transmitter in the middle, and we have upper arm and lower arm, for example, or a quite of reduced upper arm and elongated lower arm or whatever. But nevertheless,
Sure.
it has to have a sort of substitution for the ground plane so that it resembles a dipole. From computational point of view, it is very simple because the dipoles are, well, not difficult to compute at all.
Sure.
But yeah, the execution of this project is not very easy. There are many questions of flight mechanics. There are many thermal questions and electrical, maybe not electromagnetic, but many electrical compatibility, which is extremely crucial in flying very long metallic objects, especially through clouds.
Sure.
But
I'll also add, wouldn't one of the concerns for the channel of VLF antennas is thunder events and lightning strikes? If you're getting really close to the sky, aren't you increasing the odds of like either interference or having stronger noise due to like lightning or thunder events?
Well, when we are getting closer to the clouds, and practically regardless of the type of the clouds, it can be a simple cumulus cloud or a nimbus stratus, which is a layered storm cloud, the antenna always starts to gather electric charge on it and always manifests corona. It means that the antenna constantly loses electric charges in impulses which appear on the entire length of it, always. Of course, the most dangerous thing is the lightning strike, which usually means, or practically almost all the time, means that there are actually two lightning strikes, one from the upper part of the antenna and one from the lower part of the antenna. It's always bidirectional. And the most dangerous thing regarding these phenomena, maybe not the lightning strikes because they appear usually, well, it's a very rare phenomena.
Sure.
But the corona itself, it may not only damage mechanically the wire, which simply may break, and that's from the point of view of from legal point of view,
Sure.
Flying, that's completely something that must not happen at all. But this kind of electrical phenomena appearing on the wire, well, do create a certain additional load on the power amplifier. It can easily overload the transmitter. So we have to somehow omit the corona, because we cannot reduce it to zero. We have to somehow manage the risk of corona. Assume that it will appear for 100% on the wire, but how could we somehow cope with it, live with it, so that the transmitter stays safe?
Can you mitigate the corona effects by just making the wire like much thicker? Because to my understanding, corona effects has something to do with how thin your wire is, and that makes it easier to break, right?
Yes, exactly. But we are flying a balloon. And if we make something larger, the masses increases. So we may have a much reduced corona, but we cannot lift off because it's simply too heavy. So it's always a question of a balance, of an optimization between many, many factors, with the main factor being, of course, the total mass, the total payload of the balloon, which in my case, in my experiments, did not surpass 4 kilograms. The entire VLF transmitting system with 200-meter long antenna with electrical length of 400 meters did not went above 4 kilograms. So it was very, very light.
Yeah.
And but the corona itself, how can we mitigate this? There are ways of concentrating the corona discharges along in certain parts of the design. There are ways to design elements which are able to gather most of these corona phenomena around them, so that this does not appear in such intensity all along the wire. Well, of course, the question is, how could we protect the transmitter from being overloaded by this? And this is very, very complex, and especially if we are considering a very light balloon mission, which is most legally attractive, but well, from engineering point of view, it is a challenge because it's just 4 kilograms, or must be below 4 kilograms. We cannot fit the transmitter with a system that would detect any kind of overload and cut off the transmitter of the antenna, where such systems are employed on terrestrial installations and terrestrial stations. LF, VLF, that's something that is usual, but it gives a lot of weight to the balloon. So we must do something different. We can design the transmitter to be a little bit larger than needed.
Sure.
So that it is able to take this overload and stay safe during those corona events. We could manipulate with the transformer of the antenna to provide a different to provide much lower coupling between the transmitter and the antenna. It affects the performance as it reduces the radiated power, but it also works in reverse. If something happens on the wire, it wouldn't have such severe impact on the transmitter. The simplest thing would be, of course, to disconnect the transmitter from the antenna when the mission is flying through the clouds, so that what happens on the antenna stays on the antenna, the transmitter stays safe, and it starts operating just above the cloud layer. But it's, well, another system which requires additional payload. So yeah, it's a very difficult optimization, very difficult choices have had and have to be made. Have to be made when designing such robust but light stratospheric balloon mission.
Go ahead. You're saying hopefully?
Well, I wanted to add that I have managed to successfully perform these experiments.
Okay.
I have solved these problems. I have made my analyses and experiments, and I have made this transmitter running. I'm finishing my PhD, means analyzing these data and comparing them to other types of experiments and simulations. And well, for now it looks very promising. It works. It worked. So I'm very happy about it.
Yeah, and that's actually part of what you presented at the Antennas and Propagation conference. This is actually how we met. We presented in the same session, and I was presenting on CubeSat antennas, and you were presenting on deployable VLF antennas.
Mm-hmm.
So that's actually quite nice. It's kind of funny how that's how I ran into you in the first place. So I'm very happy to hear things are going well with that. But you mentioned all the challenges on the transmit side in terms of channel and receiver. Are there any complications on the receiver side, for example, or any issues for the channel itself? Like you mentioned, the coupling.
Mm-hmm.
Is that an advantageous thing? Can it be problematic?
Well, if we want to protect our transmitter from anything that happens on the wire regarding the corona events, and we decide that we want to have a reduced coupling between the transmitter and the antenna, then yes, we would lose some of the performance, and it would require the receivers to be much more sensitive than for another case when we employ a different kind of transformer. It was a challenge. It depends strictly on where exactly the receiver is located, with which type of antenna exactly does it operate. And of course, it depends on the total type of signal coverage from the antenna, because it also has maximums and minimums. So, well, if the receiver is very, very good, but is located at the minimum of the VLF signal, that the so-called first minimum, where the signal drops to almost zero and then rises up again after a few hundred kilometers, well, then it's of course almost impossible to register this any kind of signal in this minimum. But yes, this requires such relatively low power experiments and sufficiently robust to survive the clouds, the storms, the corona, and so on. It requires the receivers to be very, very sensitive. For my case, the most sensitive receivers have reported the background noise level at around minus 100 to minus 110 dBm. Many receivers had about minus 80, minus 90 dBm, and this was not sufficient. Wow. So yeah, minus 100, minus 110 for dBm for very low frequencies.
For receiver sensitivity?
Once again?
What is that value, receiver sensitivity?
That's I meant the noise level.
Oh, the noise level. Okay, sure.
Yeah. Well, of course, it meant that the receivers either had to be equipped with a long wire antenna, for example, or a magnetic loop antenna, or simply they had to be located in the rural area, somewhere outside of the cities. And they quite often were located in those locations. But they successfully managed to receive the signal. There were a lot of help in the process of registering my experimental signals came from the Alexander Association, which operates the Grimeton radio station in Sweden. It's a 1924 VLF station. It's a UNESCO site.
Wow!
So they have a wide group of people who listen to their special transmissions, which take part twice a year. So they mobilized this large group to listen to my transmissions, and it was very, very successful.
Wow.
Of course, from scientific point of view, it would be perfect to have a uniform type of receiving software, receiving antennas, maybe the receiving end located on over large area on the continent. But the fact is that there are so many different hardware types, so many different receiving antennas, and so many different environments in which they are working, that it is extremely difficult to employ something that is uniform if we do not set it up by ourselves. So I decided that I would, at least for these first experiments, maybe even crude experiments, but something or somebody has to be first, that I would rely on the equipment and the capabilities that are already known to those who listen to these frequencies. I mean, these people know very well how to use their software, how to reduce the background noise or any kind of interference at their locations. So
who are these guys? What are they called?
Well, these are the group of listeners from the Alexander Association. I mean, they do not belong to the association per se, but every time that Grimeton's radio station is active, they are able to give listener reports, and many of them do have quite sophisticated equipment producing power spectrums, and also power spectrums in time, giving a view on how the signal changed in
Oh, very
time.
cool.
This
Like
was very important.
spectrograms.
Yes.
Those usually look very nice, like the waterfall ones.
Yes. Well, in my case, the signal was very, very weak, so the spectrograms look different.
Yeah.
And but there was a lot of static. But nevertheless, some of the spectrograms did show my signal, and I'm sure that this was not any kind of interference, for example, from electrical fences or whatever. This happened, of course, as well in the past. But my signal was easily distinguishable in some of the reports, some of the cases. And what is important, the behavior of those spectrums, of those signals reported, is pretty much consistent with the simulations.
Oh, very cool. So that was almost like a free experiment.
Yes, so it's I'm very excited about it, that it actually worked, and it has hands and legs, as we say in Poland.
Sure.
There is a lot of potential in it, and I hope that it would bring something more to the propagation of the VLF, as well as the ultimate thesis that I have put, that I came up with, is that the higher we fly, the lower the apparent frequency of our transmission. I mean, we may start at a given frequency, but the higher our emitter is located, the more it behaves as an emitter operating on a lower frequency. For example, if what is
the physics phenomena that cause that? Is that Doppler shifting, or why does that happen?
No, we are moving the emitter more closer to the middle plane of the terrestrial waveguide, and the composition of the propagation modes change. This is the main link. The modes of propagation, the change of altitude, and the change of altitude corresponds by this to the apparent change of frequency. So that if we start operating, for example, at 14.2 kilohertz, that was my experiment.
Sure.
And we fly up to 30 kilometers of altitude. That's nearly the halfway to the ionosphere, which was defined at 80 kilometers. Then our transmitting frequency is apparently reduced to 11.4. So that the attenuation is lower, the first minimum of the signal shifts, and well, of course, the signal intensity in many points fluctuates, but usually it gets higher. And this is precisely what was confirmed in the listening reports. Looking at the simulations, I see the listening reports. The listening reports confirm the simulations.
Sure.
So it really can be explained like this. Well, the ultimate goal of my work initially was to somehow try to make this VLF signal travel using the zeroth mode of propagation, so that we do not have a very complex form of electric and magnetic field inside the waveguide, the terrestrial waveguide. But what we have is a most classic radio wave with vertical electric field, horizontal magnetic field, and it travels over large distances like this. But I found out that it is still very difficult to achieve using airborne transmitters. It could be achieved if we operate such transmitter at around 6 to 7 kilohertz of frequency. But this would require very, very long antenna, because the efficiency would drop severely. Just another small contribution to the VLF technology.
Yeah, absolutely. That's amazing. It sounds it's very cool that you're making advancements on two very different areas, very large things and very small things in parallel. So I mean, I can't help. I think now is the perfect time to ask someone like you with all this experience and knowledge in the fields of engineering and science, what advice would you have to engineering students, especially like undergraduates, people still not sure what to do with their lives, not sure what career to pursue? What's some general and technical advice you'd have for those students?
Well, I think that first of all, define what you like, what gives you a lot of joy, what gives you a satisfaction regarding your studies and your plans. Do not force yourself to do something which does not give you any kind of satisfaction. If you want to choose studies A instead of studies B, but you chose studies B because of somebody forced you to do so, maybe it would be wiser to come back to studies A because, well, ultimately, this is your life. And ultimately, it would be your decision. You're growing older. So it's time to define what really makes you happy and what really gives you a lot of profits and a lot of perspectives. If you have already decided on your studies, you're studying, you're happy, please remember that there are many other students similar to you. So in order to gain more experience, especially hands-on and learning by doing experience, and make yourself stand out, for example, for your future employer, if you do not plan to create your own company, please consider more activities, especially in students' associations, in NGOs, maybe in some additional internships. Yep, that's the word. In order to gain more experience, in order to already start doing some projects. They do not have to be very complex. They can be even very, very simple. But it would mean that you are able to create something that stays outside of the plan of your studies. It means that you can think as an independent person. It means that you can take up a challenge and finish it. It means that you are very, very valuable for your future employer or as a future scientist or as a founder for your future company. If you want to do more experiments and doing, well, a lot of science, well, for example, I'm a big fanboy of Marie Curie, or as we say in Poland, Maria Skłodowska-Curie. And she said that doing science is like reading a fairy tale. It's discovering more new things that give us an enormous excitement and joy. So if you are very much into that, please remember that your life is not composed solely of this. It may be surprising to say, but from my experience, I must say that there were some periods in my life when I had to remind myself that it is not my science, my analysis that rules my life, because it is my life. I rule my analysis. If something goes wrong, if somebody complains about it, if somebody gives me bad reviews or comments it in a way which I dislike, it may happen, but it doesn't mean that you get somehow damaged with it. It means simply that you're doing science, and science is by default meant to be falsifiable. If it's not falsifiable, then it's a heresy. So do not be very much concerned with this. Be able to relax. Find your time to stress yourself out, to separate somehow from your activities in order to recharge your batteries, which not necessarily have to be nuclear, and to gain more power in order to pursue the science and become more resistant to life, because life is not only composed of things that are pleasing, and even in the scientific community. And science is not the only thing in your life that would help you to maintain balance. I know you love science. I know you love experiments and so on. And if something goes bad with some of these experiments, you'll be very, very much worried. So please remember to have not to take everything seriously, be able to disconnect somehow from it in order to maintain mental balance. It's very important for you to keep the mental balance. This would make you feel much, much better. And well, I think that's it. I think that's it. The last part came from my recent experience, which also contributed to my, let's say, maybe not aging, but my growing as a future senior scientist, where my abilities are transforming from a wannabe experimenter who sits with some very interesting books in in a cellar with other students to somebody who does very important grants with very high money backing and does groundbreaking experiments over large field in adult world. So yeah, I think this is very difficult, the difficult non-material part of a PhD that every PhD has to come through. But if you do come through this with success, then I'm sure your scientific activities in the future would be much facilitated.
Wow, man, that was probably one of the best advice I've ever heard, because you mentioned about following your curiosity and doing what you like, and also managing yourself emotionally, and accept that being a scientist, expect things to go wrong. If things are going right all the time, you're probably not taking big enough risks or working on interesting enough problems, right?
Yes, or simply you're not doing things that would make you to stand out, because you're not doing something which is new enough or groundbreaking enough. Groundbreaking always meant problems or issues, not only of the material type.
Sure. Well, I think this is the perfect place to end. Tomasz, thank you so much. This is wonderful conversation. I'm quite confident anyone who will watch this will gain tremendous value out of it. Thank you so much. And who knows, maybe we have a part 2 in the future. As always, say hi to your cat as well.